watching the 2.3 lesson video of domain and range notes. Okay, so last year you talked about domain and range. I'm hoping that some of this is review for you. So if you are talking about a function, the domain is the set of all x values. So domain is the x values, and sometimes it's also called input because you put it in, and the range is a set of outputs or y values. So just remember domain x, range y. All right, if we look at exercise 1, list the domain and range of each function shown below. I'm going to do some color coding. A point is written as x comma y, so I'm highlighting all of my x values in yellow. So 1, 3, and 5, that's the domain. And then the range is the blue, 5, 7, and 9. So I could highlight that blue. I'm writing super fast, so it's super sloppy. Let's do the same thing for B. So B, we're dealing with all of the points here. I'm just going to take a minute to label the points. All right, so here I have all of my points labeled. I'm going to do the same thing. Hopefully I have those all right. I'm going to highlight the domain, the x values in yellow, and all of the range values in blue. So all we have to do is list them. I'm going to go from small to big for the domain. So -3, -1, 2, 4, and 5. And that's set notation, and then the same with the range. The range is what, -3, then -1, then 0, 2, 4. All of the blues. Okay, so we can get the domain from a set of points listed, we can get them from a graph, or we can get them from a table. Table's super easy because they're all listed right in there for you. So there we have our domain, -8, -6, -4, and -2, and then the range, all the y values, 1, 2, 3, and 4. All right, cool. Now, this is like a huge question that the Regents exam loves to ask. So they give you this real life situation and they ask you the number set that is best used to describe either the domain or range. So let's read. A construction company uses a function f of p where p is a number of people working on a project to model the amount of money it spends on the project. Okay, to model the money it spends on a project. So what's happening, let's just think about the situation. We put in people into the function input, and then what do we get out? We get out money. So this is our in, our out. Another way to look at it would be x and y. So all of these on the left side match and all of those on the right side match. So they're saying a reasonable domain. So we're looking at the domain. Domain, the x values, the in, which is people. So when we're describing people, we definitely don't want decimals of people, right? Positive and negatives, we don't want negative people, that's weird. So that's not going to work for 3 or 4 because of the negatives. We don't want any negatives. How about positive real numbers? Well, real numbers could be rational or irrational, lots of decimals and fractions. Ew, definitely not number 2. Positive integers, on the other hand, and this is a really nice number systems reference to go back to, but integers, the positive integers would be 0, 1, 2, 3, so on and so forth, which would make a lot of sense when we're talking about counting people. Okay, here's exercise number 3. An online company lets you download songs for 99 cents after you have paid a $5 membership fee. So what range? Okay, so we're dealing with range here. We're dealing with the y value. So if I were to label a table of values, here's another way of thinking about it. What would you put in for the x's and what would you put in for the y's? Well, an online company lets you download songs. So we're dealing with songs, and then we're going to get out what? Money? So we're going to put in songs, and then we'd figure out how much it would actually cost us per song. Okay, so let's think about it. We now need to describe money. Well, money doesn't have to necessarily be whole numbers, right? We could have like $3.45. We don't just have to have $3. So let's look at our answer choices. A lot of times with these questions, it's process of elimination. So it's very important to read all of the answer choices. I can't stress that enough. Sometimes we might think answer choice 2 is the best and then realize 3 was actually even better. So number 1, rational numbers greater than 0. So decimals bigger than 0, or okay, I think I might like that one. I'm going to hold off on it. Whole numbers greater than or equal to 1? Well, technically you could have $0, so I don't like that one. And whole numbers means that you wouldn't be able to have like $4.53. It would just have to be $4. Doesn't make sense. Integers less than or equal to 0, that's negative numbers. That would be really weird for money. Whole numbers less than or equal to 1. More negative numbers, not flying with me. I'm digging number 1 because rational numbers greater than 0 makes the most sense. All right, onward to the next page. All right, if you have a highlighter, well, how about this? Go grab a highlighter if you don't have one and pause the video. Because what we're going to do here is we are going to look at the domain and range. Remember, the domain is the x values. So we are only going to be looking at the x-axis. It's very important to only look at the x-axis. And notice how I just used my highlighters to kind of scrunch in my function. I only care about this part of the graph because this is the only part of the graph that I can actually see my function on. And more importantly, I only care about the start and finish of those x values, -4 and +4. So in interval notation, that's pretty easy. -4 to 4. And let's be careful. Is it included? Well, how are we going to tell? By looking at the endpoints. Yeah, they're closed. So square off those brackets. Had that been open, we would have rounded the bracket. And then the inequality notation is super easy. Less than or equal to x is less than or equal to 4. So the same two numbers are the same. Put an x in the middle, less than or equal to. All right, let's do the same thing with the second one. Okay, here and there, we only care about this in between. So what is that? 1, 2. Actually, no. We care more about this number. 1, 2, 3, 4, 5, 6. Okay, so 1 to 6. 6 is most definitely included because see the points closed off right here. But 1, on the other hand, that's an open point. So when we convert that, this is definitely review from last unit, converting between interval and inequality notation. But remember, less than symbols all the way through, and then we're not going to put an or equal to because of this rounded bracket. All right, lastly, here we go. From here, all the way to, whoa, we could like go on and on forever. Interesting. Okay, so what value of x is this? 1, 2, 3, 4. That's -4. So x is always bigger than -4, isn't it? All right, I'm going to do my inequality notation first. X is always bigger than -4. Can it equal -4? Yes, it can. So bigger than or equal to. Now, if you think about this in interval notation, we start at 4, it can equal 4, but it can go all the way to infinity because of this arrow here. And remember, infinity is nice, cute, and rounded, so it gets a nice, cute, rounded bracket. All right, range. You got it. We're going to do the y values, which means we're not going to go from left to right anymore. Actually, let's do that. Left to right. we are going to go low to high. Okay. Remember, we're dealing with y's now. So how low can the graph go to how high can the graph go? So how low can you go to how high can you go? There, oops, I went a little too high. I think this is it. This is how high it goes. And that's how low it goes. I like this better. So what number is that? It's 3. And then how low is it? -5. Well, both of those points, are they closed? Sure are. So -5 all the way up to 3, close, close. And -5 is less than or equal to y is less than or equal to 3 because it's included. Okay, let's do the same thing here. Remember, we're dealing with the up and down values, so I only care about the y-axis. That's why I'm doing a slice. Now, a lot of people might want to highlight here. No, 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 this goes even higher, doesn't it? To there. So we're looking at how low it goes to how high it goes. How high is that? 1, 2, 3, 4, and it starts out at -1, -2, -3, -4, -5. So here we go from -5 all the way up to 4. 4 is most definitely included because there's not a weird open point there, but at -5, not included, rounded. So -5 is less than y, because of this bracket there, is less than or equal to 4. All right, next example. Interesting. Well, this has the arrow on the end, which means we have no limit. This just goes up and up and up and up and up. So y is always going to be bigger than or equal to what value? -1, -2, -3, -4, -5. So -5 is the low and positive infinity is the high. Low to high just keeps going on and on forever and ever. So closed and open. Okay, and just to save some time, because I know this video is getting really long, I just went through and highlighted so it's easier for you to see as I talk about the examples. So interval notation is what we need to use because that's what it says up here. Domain is from -7 all the way to +7, and I'm skipping 8 because it's already done. And what are we going to do with those brackets? Ooh, both of those points are open because we need rounded parentheses or rounded brackets. The range is from low, so -10. I'm looking at the yellow here, all the way up to +1. And 1 is included, but -10 is not rounded. All right, the domain goes from, let's see, ooh, the domain starts at -infinity. See how that arrow means that we're going to go back, 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 back forever and ever? Round it off all the way up to blue line, 7 included. Range, how low can you go? -8. I'm looking at my yellow. It's included, and it goes all the way up to infinity and beyond, because look at that arrow. I almost thought it was here, but I just saw the arrow, meaning that it goes all the way up to infinity, rounded off brackets.